Back to some more graphing today with exponential graphs, and then we'll deal with some exponential equations towards the end. An exponential graph has a parent function, if you will, of this y equals b to the x, where b is known as the base. Now, there's a lot of bases. We have a special one called the natural base. If you ever see an e in your problem, that is basically a constant, kind of like pi. That constant is roughly about 2.718. So just letting you know, e is the natural base. So anyways, getting back to these exponential functions, if our base is greater than 1, we say this problem has exponential growth, which means it's going to increase at an exponential rate. If that b value is between 0 and 1, or a fraction basically less than 1, we say that's exponential decay, which means that's going to fall. And let's take a look at two parent functions, if you will. These are both parent functions, just the bases are different. All right. If we want to graph this, you basically go to your tables. So let's go -2, -1, 0, 1, and 2. I plug in a 2, I get a 9, a 1, I get a 3, a 0, 3, sorry, 0, I get a 1, -1, I get 1/3, and 1/9. So then I graph that. This should be a growth problem. So I have 0, 1, 1, 3, 2, 9, 1/3, and 1/9. Like so. And you'll notice this is never going to drop below this line, because what power of a positive number gives you a negative number, and that's never going to happen. So we can really say that there is a horizontal asymptote here that this line approaches, and in this case it's never actually going to cross either. When we go over to this side and we make our table here, again, -2, -1, 0, 1, and 2. Plug in a 2, I get a quarter. 1, I get a half. 0, I get 1. -1, I get 2. -2, I get 4. Go ahead and graph that. Here's -2, 4 up. -1, 2 up. 1 or 0, 1, half and a quarter. So this is going something like this, and again you'll notice not going to cross that horizontal line of the x-axis, and we'll just draw again another horizontal asymptote right there. So we can play around with this a little bit. We can start adding HKs and A's and B's and so on and so forth. Again, so let's identify ABHK. And in this case, there's no multiplication out in front of this base of 2, so that's 1. Within the fraction, or within the function itself, the power, there's nothing, that's 1. H, -4, K, -1. Go back 4, down 1. Again, I put my little crosshairs. I look at my parent function, which is 2 to the x. -2, -1, 0, 1, and 2 again. Start popping numbers in. I get a quarter, a half, 1, 2, 4 from this new point. So here's my 1, my 2, my 4, my half, my quarter. Goes something like this. Looks like I have the point -2 and what is that, 1, 2, 3. So I'll check that in just a second. So I know that horizontal asymptote is going to be right here now. Let's go check the point -2, 3. So I put a 3 right here. Say 2. That's -2 plus 4 power. -1. This is 2 squared, which is 4, -1, which is 3, checks. So here's an example that has pretty much everything in it. We've got an a value, which is the multiple out in front of 2, a b value, which is in the division of the power, which is 4, an h value of 1, and a k value of -7. So again, I'm going to go over 1 down 7, put my crosshairs there. Then I'm going to look at my parent function, which is 3 to the x. This is my x and this is my y. -2, -1, 0, 1, and 2. For 2, I get the 9, a 3, a 1, a 1/3, and a 1/9. But like we said, we've got an x multiplier and a y multiplier in this case. Y multiplier of 2, so that's 2/9, 2/3, 2, 6, 18, and a x multiplier of 4, it's -8, -4, 0, 4, 8. And start with 0, 2. It's going to put us here. Go over 4, up 6. So that puts me right around here. Over 8. And up to 11. In this case, because that makes 16. Then I go back 4, up 2/3. 1, 2, 3, 4, up 2/3. And back 8. And up very little. Graph this guy so you see it's stretched. And it increases a lot more. I'll put my horizontal asymptote in there. Right here. And check a point, always do that. Let's go with, it looks like it's supposed to be 5 and -1. Hopefully I counted right. Let's check this point. So if I go -1 equals 2 times 3 raised to the 5 minus 1 over 4 minus 7. So here we go. This is 3 raised to the first power times 2 is 6 minus 7, which is -1, and it checks. All right, so we're going to solve some exponential equations, and not meaning to insult anybody's intelligence, but what can you glean from this fact? If 2 to the x is equal to 2 to the 5th, what does x have to be? Well, obviously it's got to be 5, because if the bases are the same, then the powers have to be equal. All right. Now, that's only the case if you have one base on this side, one base on this side, and they're both isolated. So when we go over here, 3 to what power is equal to 7 to the 6? This, impossible right now. Notice the words right now. The goal by the end of this section, or not today's section, but by the end of this exponential investigation, which is going to take a few days to a week, is to be able to solve for a value of x. So let's go to the next example. Very similar, except there's not just one term on each exponent. But I know the bases are the same. They're isolated, one on each side, so I can set the two powers equal. And basically just go ahead and solve. So x is going to equal 9 in this case. Now, the bases aren't the same. However, I know I can rename 9 to look like a 3 because 9 is basically 3 squared. And that's 2 the x plus 1 power, and that's equal to 3 to the 4x plus 5. We have a property of exponent that says take and multiply those together, so that's 2x plus 2 equals 3 to the 4x plus 5. And now the bases are the same, so I set 2x plus 2 equal to 4x plus 5. So 2x equals negative 3, and negative 3 halves is equal to x. Similarly, I have a base of 4 here and a base of 1/2 here. I usually like going to the lowest term, so 2 is my low base, I'm going to say, and if I can put both these in a base of 2, I'm happy. 4, not a problem, that's 2 squared. Raise the 2x. 1/2 is 2 to what power? And we know that is 2 to the negative 1 power. So now I'm going to have equal bases. I'm just going to clean it up and get 4x here, get 2 to the 2x minus 1 here, set the powers equal. 2x will equal negative 1, and x equals to negative 1/2. And then lastly, again, two terms. My low base can't be 9 here because it could, but I don't know offhand what power of 9 is 27. But what I do know is I can make both these a power of 3. 27 is 3 cubed, and 9 is 3 squared. Simplify each of those, so that's 15x and 2x plus 10. So 15x equals 2x plus 10. 13x will equal 10, and x equals 10 over 13. And that's all there is for today. We'll talk to you soon.